Carbon is element number 6 on the periodic table. It's so important in chemistry that there's an entire branch of chemistry devoted to studying carbon-containing compounds, and that's called organic chemistry. For climate change, it's important to understand the global carbon cycle that quantifies all carbon atoms on Earth, including in the atmosphere and underground. So this is carbon moving through the Earth's underground, surface, and atmosphere through all living things. The focus on the carbon cycle is carbon dioxide in the atmosphere that is the chemistry behind global warming and climate change. So let's look at the carbon cycle. This is in today's worksheets. And what this is the global, around the world, on Earth, underground, on the surface, and in the atmosphere, the movement of carbon atoms. So we can see first the units are in GT. You should recognize this G. This is giga, the metric prefix, and that is 10 to the 9. So GT is a gigaton, and that's going to be 10 to the 9 tons. So a value like this, it says 750 GT, is a huge number. So it's the 750 times 10 to the 9 and tons. And let's go back to what a ton is. So 1 ton, well, we haven't actually covered that. 1 ton is about 2,000 pounds. It's over 2,000 pounds, but 2,000 pounds. So if you see a number that says 750 gigatons, that means a big, big number. A fully loaded 747 airplane, fully loaded 747, weighs 800,000 pounds. So it would take 3 million fully loaded 747s to have a total mass of just 1 gigaton. That would be just 1 gigaton would be 3 million fully loaded 747s. So first, there's the atmosphere. This is this circle. Atmospheric carbon, which is in carbon dioxide, CO2. So this is carbon dioxide gas in the atmosphere. And there's some atmospheric carbon that's trace amounts of carbon monoxide, but the atmospheric carbon dioxide is what we monitor, and what we're monitoring now is about 400 parts per million of atmospheric carbon dioxide total. And this is current day. So this is number 1, is atmospheric carbon dioxide. And that's number 2, let's do in green, is underground. So these are underground, down below, and this is rocks, okay, underground. This is fossil fuels, also underground, and sand and silt. These are reservoirs, and these are underground, and they're stored. They are meant to remain underground, and they're also indicated in black. So in these black, these are not part of the atmosphere, but they are meant to be stored. And the problem is that what we humans have been doing is pumping these fossil fuels out from underground to use as gasoline or oil, petroleum, methane gas, and we've been using these and putting this into the atmosphere as carbon dioxide in combustion reactions. So that's part of the chemistry behind why we're experiencing climate change. So this is also sand, rocks, but this main problem is fossil fuels. That is the burning of fossil fuels, and so pumping up the oil, petroleum, bringing out the natural gas, the methane gas, is then used to burn in combustion reactions. So that's not necessarily meant to happen. All of that are underground stores, and they're meant to stay underground in this natural carbon cycle. Orange, there's also carbon in living things. So that's like the forest. This is soils.
There's living things in the surface water, microbes, and in the deep ocean. This is in living things, including us. We also contain carbon. So humans contain carbon, plants contain carbon. These down here I should add are the fossil fuels. This is dead organic matter. Those were once living things. But this all together, this is the blue, the orange, the green, is a natural cycle that has been established, was established as part of Earth's evolution. It's an equilibrium or a homeostasis. So this is an equilibrium, or if you're more familiar with biology terms, a homeostasis, or just thinking about just basic words, this relies on an equal in, equal out. What goes in, what comes out, and it's a cycle. Okay, and so this was a natural cycle established through the billions of years that Earth has existed, and this is has been disrupted. What's indicated in red are this deforestation, respiration, reforestation, photosynthesis, burning fossil fuel to and from the ocean. Anything indicated in red is carbon moving through the system. And so this is how they're coming into and forming part of the carbon dioxide in the atmosphere. We have respiration, we have deforestation, and we have burning fossil fuels, and we have from the ocean. Okay, but this is carbon dioxide going into the atmosphere is also removed from the atmosphere for most of these in equal processes. Where does carbon dioxide come from? These carbon dioxide emissions. This is atmospheric carbon dioxide all over the earth. The sector that's highest is this power and heating stations, 26%. These are coal-fired power plants. We'll talk about that. We've already talked about it for air pollution. And coal-fired power plants are generally used by countries all over the world to generate electricity. That's to generate electricity for the grid. So you can call it electricity or power generating station, but it's generally electricity. The next is industry. This is making stuff. So this is factories that are making stuff, and they're also burning, generally burning coal, but sometimes other hydrocarbons. But they're usually burning coal, and any hydrocarbon is going to burn and produce carbon dioxide. So then there's deforestation. This is basically cutting down trees. Are not just trees, but entire forests. And transportation. There's a lot of focus on transportation in when people say I'm gonna cut my carbon footprint, which is part of your homework this week. Actually, is to determine your own contribution to atmospheric carbon dioxide. But cutting your carbon footprint is always a good idea. But transportation is not necessarily going to be the trick. It's not always going to be buying an electric car or taking the bus or riding a bike. It's a small factor. In fact, saving electricity, or in fact in agriculture, the food you eat has the bigger impact than transportation. Of course, anything you do towards sustainability and using alternative energies is always great.
Now let's go back and understand the information in this worksheet.